Welcome back, Dragons. A few moments ago, we worked on page 68, comparing ratios, and a few days ago, we worked on introduction to ratios. After that came representing equivalent ratios. And there are actually about a total of 5 ways in which we represented equivalent ratios. One was tape diagrams, double number lines, and proportions. 1, 2, 3. The other 2 were tables and graphs, which will be on the following page. So this is going to be page 69 in your interactive notebook. Again, if you don't have a printer, feel free to write this out by hand. This won't be due today. You do have an extra week to do all these interactive notebook pages. So let's walk through it. We got a lot of good vocabulary on this one. I can use ratio reasoning with equivalent and whole number ratios to solve real-world and mathematical problems. I got this from Carnegie Learning. So you've actually done some of these activities already. So your word bank, proportions, scaling up, double number, line, I'm sure it meant to say. Perhaps, we'll find out. Units, rate, equivalent ratios, tape diagrams, scaling down. Blank blank are ratios that represent the same part to part or part to whole relationship. So from your word bank, what do you want to put in? If you said equivalent ratios, you did fantastic. Equivalent ratios are ratios that represent the same part to part or part to whole relationship. A blank blank illustrates number relationships by using rectangles to represent ratio parts. Which type of representation uses rectangles? A tape diagram. A blank is a ratio that compares 2 quantities that are measured in different blank. A rate is a ratio that compares 2 quantities that are measured in different units. Units and rate. When 2 ratios or rates are equivalent to each other, you can write them as a. When 2 ratios are equivalent to each other, you can write them as a proportion. When you change one ratio to an equivalent ratio with larger numbers, you are scaling up. When you change a ratio to an equivalent ratio with smaller numbers, you are scaling down. All right. A blank blank line is a model that is made up of 2 number lines used together to represent a ratio between 2 quantities. A double number line. Excellent. All right, got the vocabulary done. Moving on. Tape diagram example. The local bakery sells muffins in variety packs of blueberry, pumpkin, and bran muffins. Blueberry, pumpkin, bran. They always sell the muffins in a ratio of 3 blueberry, 2 pumpkin, and 1 bran. Suppose you purchase an 18-pack of muffins. How many blueberry, pumpkin, and bran will you purchase? Well, let's analyze. How much is normally in a pack? 1, 2, 3, 4, 5, 6. But they're saying instead of having 6, you're going to have a total of 18. This should start to look familiar. So how many would have to be in each box, each rectangle, to get us to 18? Can you think of a fast and efficient way to solve this? Well, if normally there are 6 boxes and you have to get 18, 18 divided by 6 rectangles would result in 3 per rectangle. So we have 3, 3, 3, 3, 3, 3. They always have to be the same amount in each rectangle in a tape diagram. So how many blueberry muffins do you have? 3, 6, 9. 9 blueberry. How many pumpkin? 3, 6. 6 pumpkin. And how many bran? 3 bran. Quick addition check. 9 plus 16 is 15. 15 plus 3 is, in fact, 18 total muffins. So that's how you use a tape diagram. Your first ratio was 3 to 2 to 1. Your new ratio is 9 to 6 to 3. What does that look like? What am I saying? I am saying that 3 blueberry to 2 pumpkin to 1 bran is equivalent to 9 blueberry to 6 pumpkin to 3 bran. Those are equivalent ratios. All right, I'll leave that there for a moment for you to get that copied down. Next, we have a proportion example. A proportion is when one ratio or rate is equal to another ratio or rate. They have to have the equal sign between them. And we can either scale up or down to work these out. Now, I am looking at 2 blueberries muffins going to 20 blueberry muffins. What multiplicative relationship exists between 2 and 20? Times 10. So I would have to do the same exact thing over the equal sign. It would have to be times 10. So the multiplicative relationship is times 10. And when we're going up like this, we call it scaling up. So 5 times 10 is 50 total muffins. Next, 12 hours down to 4 hours. 2 ways you could represent this. You could represent it, since we're going down, you could represent it through division, which is the inverse operation of multiplication, or you could represent it by multiplying by a fraction, which gets you the same effect as the division would get you. To avoid any confusion and not scare anybody with fractions, I'll just use division. So 12 divided by what gets you 4? 12 divided by 3 gets you 4. So repeat the process over here. 720 divided by 3 gets you how many miles? Not sure? We can work it out. No problemo. 3 goes into 7 twice. Bring that down. 4. 0, bring it down. 0, 0. Bunch of zeros going on. Okay. 240 miles. So that was called scaling down. Now, scaling up and down is not exclusively used on proportions. You can scale up and down on the tables, the double number lines. It works in other situations as well. Let's briefly talk about what was the same as dividing by 3. Dividing by 3 is the same as multiplying by who? Multiplying by 1/3. So you could have gone that route. Make sure you get those notes down. Last example on this page is a double number line example. One of the lines represents bananas and the other one represents the cost. Notice that it's bananas in pounds. Cost is in, looks like customary US dollars. 1 pound of bananas costs 64 cents. Use the double number lines to determine the cost of each quantity of bananas. Let's see if we can just test out a couple. I like to check what kind of scale they're drawing on. For example, 1, 2, 3, 4 spaces to get to 1. So 1, 2, 3, 4 spaces to get to 2 pounds. 1, 2, 3, 4 spaces to get to 3 pounds. 1, 2, 3, 4. 4 more spaces to get to 4 pounds. So I have all sorts of pounds. What do I do to get from here to here? What multiplicative relationship exists? Times 2. What about from here to here? Times 3. And here to here? Times 4. So to be fair, I would have to do the same thing on the other line. So this would be 64 cents times 2. Or 64 cents times 3. Or 64 cents times 4. So we're going to find our solutions for these. 64 cents times 2. $1.28. 64 cents times 3. $1.92. 64 cents times 4. $2.56. Going with the calculators. Make sure we're right. 0.64 times 2. Check. 0.64 times 3. Check. 0.64 times 4. Check. So if 1 pound of bananas costs 64 cents, then 2 pounds of bananas cost $1.28. 3 pounds cost $1.98. And 4 pounds cost $2.56. What does that mean in equivalent ratio world? It means that 1 pound that is 64 cents is equivalent to the same relationship as 3 pounds is to $1.98. You could keep going. Or is equivalent to 2 pounds to $1.28. Or is equivalent to 4 pounds is to $2.56. And if we were feeling really fancy, we could have gone all the way down and determined all these little guys. You would have done 64 cents divided by 1, 2, 3. I would have divided it by 4 spaces. What would that look like? 64 divided by 4. It would have been 16, 32, 48, 64. And that would have been just 1/4 pound, 1/2 pound, 3/4 pound to 1 pound. Could have broken it down super small. Super, super small. So I hope most of these examples seemed extremely familiar. You have worked diligently on this in the past. And now you're all set. Thank you for joining me for AIM page 69. I'm going to trim this out, glue this down, and we'll be done with that page. It will be collected during quarter 4.